right? This is the same problem. First we're going to list the possible rational roots, and then we're going to see if we can find one that works, right? If there are any rational roots here, they got to be the factors of -1 divided by the factors of 2, right? Factors of -1 divided by the factors of 2. Okay, well, what are the factors of -1? Plus or minus 1, right? So plus or minus 1. What are the factors of 2? Plus or minus 1, plus or minus 2. So if I take all the possible combinations, that's either 1 over 1 or 1 over 2. Oh, 1 over 2. Okay, so how many is that? It's 4. So we should do synthetic division. I'm just going to jump to the answer here because I know it. If you go to the 1/2 and do synthetic division, which we didn't do much synthetic division with rational numbers as zeros, but you can, obviously. 2, -1, 2, -1. Okay, 1/2 times 2 is 1. Add. 1/2 times 0 is 0. Add. 1/2 times 2 is 1. Add. Okay, now, if we were blind, if we didn't have a calculator, we may keep going to see whether those last two are, because there's a total of 3, whether the last two are rational. But the thing is, we've already reduced our polynomial to a quadratic. We know that this is where the last 2 will come from. So instead of doing that, let's just solve it. Right? How do I solve that equation? Subtract 2 from both sides. Then what? Divide by 2. X squared equals -1. Okay. Take the square root of both sides, right? And you're going to get the square root. The square root of -1 is I. So this is x equals plus or minus I. So those last two weren't going to be rational anyway. The only rational 0 was the 1/2. Right? By the fundamental theorem, we knew there's only 3, and we found that one was synthetic division, and we found that the last two are imaginary. There's 3. So there's nothing else to find.